Good morning. Morning. My name is Robin Leroy. I'm a software engineer in Google Internationalization. And I'm going to talk about Unicode source code handling, which is actually the title of one of those new bits of Unicode standardization that Marcus has shown us are very many. This is number 55. So, there are almost 54 of those before that, almost. And this is, going to cover a bit of the making of how do those 50-odd things get produced. So, shortly after Halloween 2021, a CVE, that's a vulnerability report, came out together with a paper, which is cited here. Essentially, the point of which was that you can use some Unicode characters to write code that looks like it does something different from what it actually does. And so this figure is taken from the paper. I'll work through what's going on here. This is the memory representation. So you have a comment starting here, ending there. A comment starting here, ending there. You have some funny-looking characters, right to left override, left to right isolate, top directional isolate. And the effect of those characters is to take those bits here and there and order them right to left, and also flip the direction of this curly bracket with the effect that the code looks like this, which, if you see that and you don't know what's going on in there, you might think that there is some actual code that's executable, and that's a condition around this printf. And there was some other stuff covered by the paper and the separate CVE about homoglyphs, which we've heard of in the IDNA talk earlier today. If you have characters that look exactly the same, like one of these A's is Latin, I cannot tell you which one it is, but I went through the trouble of typing them in different scripts. It's fairly easy to see how you can confuse things and confuse a reviewer. Okay, that looks scary, right? Well, so people with some familiarity with Unicode, so this made the news, on tech sites and whatnot, and obviously Twitter. Back then, it was still called Twitter. I had people discussing that, and people with some familiarity with Unicode pointed out that, well, those fancy characters have been around since 1991, so this isn't exactly the freshest news. And, Ruth Beporneder, vice chair of the script ad hoc, was discussing that, this is a pattern that we keep seeing where people get scared by some random bit of Unicode and then proceed to forget about it. Right. Okay, but, fake Unicode and Roosbay are people deeply familiar with Unicode. So maybe it's actually news to, programming languages people. Well, so this person, Chandler Caruth, is the lead for the programming languages C++, Clang, LLVM stuff at Google. He also thought that this was old news, right? And Richard Smith, a C++ standardizer, pointed out also, is it really that much of a threat? You syntax highlight this stuff, even if your source code display ends up a bit weird. That whole thing starts looking like a comment, right? And also, there's no plausible deniability. If you start doing, sneaking in code that way, and you get found out, well, you're not employed anymore. So there are many other ways to sneak in vulnerabilities that are more deniable. Okay, so why do we bother? Well, it says Unicode, so it's Unicode's fault. Right, so you had a bunch of people, again, Twitter, a bunch of people on Twitter explaining how Unicode was bringing all sorts of pestilence into the world with those BiDi control characters. Okay, but Unicode adoption, that's a battle we've fought and won 20 years ago. Again, why bother today? Well, Unicode adoption in programming languages, that is not a battle that is completely over. And there was some work in particular in the programming languages that are standardized by ISO. In the early 2000s, there was a big push to get proper Unicode support there. But this is some discussion in the standardization of a non-ISO, very trendy programming language, where they added support for non-ASCII identifiers. And they ended up doing it. But the general sentiment of the room wasn't particularly great. Had some people making comments about how this would bring about some untold catastrophes. So there is some, serious concern about adoption in that specific field. Right. And security, as we've seen also with IDNA, security often overlaps with usability issues. This is some bit of C#, and it's translated into Hebrew, and I can't read it to you in Hebrew because I can't read Hebrew. But the word error gets thrown over there. The BiDi algorithm then says, oh, this is all right to left. The word message gets translated to that. And then the closing quotation mark, sorry, the opening quotation mark here, well, that says there. The closing quotation mark, of course, is here. And the result is an illegible mess. You're not going to be misled into thinking there is something else. You're just not going to read it, right? And, well, frankly, no one was particularly caring about fixing that. So if we can use people caring about security to fix things, that's useful. And also, people see security, they think we need to do something. And the natural, the continuation of that argument is, this is something, therefore let's do it. So it turns out that you can use some of those mysterious characters to fix the display of program text. So here you have some code that's, well, the comment is here, right? You have some code with some characters here affecting the ordering of the text. And in some text editors, those characters get replaced by directionally neutral characters, and you bring the problem back. So, we need to provide guidance so that people seeing that there's a security issue wouldn't make it worse, or at least make the usability issues worse. Okay, so we need to do something. So I mentioned the CVE was from November 1st, and so this fake Unicode person who was at least at the time always discussing the latest Unicode-related news, started looking at where we could insert some guidance there. There's this Mark Davis person at the back of the room who then pointed out that there were some other places in the standard where we could stuff something. And then I started sketching an algorithm, right? So you have some sort of an algorithm there. Well, we're done, right? Print that tweet out, staple it to Unicode Standard NX9, call it a day. Okay, who can take that and turn it into code? Yeah, I'm pretty sure the guy to your left can also do that. Anybody who's not an editor of Unicode Standard NX who can turn that into code? Yeah, we have a problem of actually communicating what the problem is, what the solution means. Actually, let's start with that. What am I even talking about? So let's say we have some code written in the Latin script. Here you have a lambda expression, right? So the integral of the function that maps a to a squared from 1 to 0. Translate that to Hebrew, and it all gets messed up. The lambda expression then starts here, continues there, and then the bounds are here in the middle. Well, that's obviously messed up. So what Unicode Standard NX9 higher level protocol 4 says, the higher level protocols are a way to apply the BIDA algorithm given additional structure. And so it says, take your text, chunk it into little bits, and within those little bits, apply the BIDA algorithm. So the little bits in question, this is the desired display. We've taken the identifier here. That is still displayed right to left. That's important. You don't want to start displaying words backward, because then it's illegible. And then you take that identifier, you display it right to left, but it's a single character, so nothing interesting happens, and more of the same. Right, so that's the algorithm. But there's also an issue of discoverability here. Because you see, this fake Unicode person who is very well versed in the plethora of Unicode standard annexes and technical reports and technical standards that we have, is already, saying, then there are a lot of these. And then there's this Mark guy who says, actually, there's another one you haven't thought of. And then I'm bringing up UX9 itself. And at the end of the day, this is what we ended up touching. OK, so if you're a programming language designer, you might think of the thing that says identifiers and pattern syntax. But we'll see it's not quite obvious what you should pick from there because it's big. It also has hashtags, so there's a lot of stuff in there. And you're not going to, even if you're an IDE developer or whatever, you're not going to look at the line breaking algorithm, because if you have line breaking in source code editor, that's going to just be boring line wrapping with emergency line breaking. You're not doing pretty typography. Security mechanisms, OK, yeah, if you're looking for security, fine. Bidirectional algorithm, well, sure, you're going to look at it once you know that there's a BIDA issue, but you're not going to start with your designing your programming language, looking at that one. Yeah, we ended up touching emoji. The less said about that, the better. Right, so we had I got involved in that because I had chatted with this Mark guy, and we had a meeting in the wee hours of the morning where I was, where we decided we need to do something, and so we tried to come up with some sort of plan. We realized that we don't have within the usual suspects of the Unicode Technical Committee, we don't have the expertise, in programming language design, in IDE development, compiler warnings, linters, all of that stuff was somewhat far removed from what we did, and so we need to know whether this was understandable, whether this was applicable, whether this was feasible. So we recommended forming a working group with those kinds of people involved. And at the same time, we had a sketch of some sort of solution. It's nice to figure out what the problem is, what we are trying to solve. And so we started working on some documents where we laid out what the specific issues we had with that broken source code display was. OK, so if you have a single token lexical element, it probably shouldn't get split. And we ended up having to refine the concept of the thing that shouldn't get split. And so definitionally, we called it an atom that shouldn't get split. Those lexical elements should not influence one another, right? You don't want a left shift to become a right shift because something was happening next to it. And the homoglyph stuff was also a concern. So, HTTP and TTR, well, that looks identical. But then we end up in a slightly different situation from the IDNA world, because you actually need to support mixed scripts, right? HTTP zapross, Russian for HTTP request, is an identifier that you will find widespread in the wild. And so you need to support that stuff, even though that's out of scope in other identifier confusability issues. And since you need to support mixed scripts, you end up with scripts that have different directionalities. And so you end up with this situation, which we had carefully avoided up to now. This thing could be the Latin letter 1, the Latin letter A, followed by the digit 1, followed by the Hebrew letter Aleph. It could also be the Latin letter A, followed by the Hebrew letter Aleph, followed by the digit 1. Those are going to look identical. And so we had to, we found out about this problem. We had to do something about it. Actually, we did something about it. All right. So we came to the Unicode Technical Committee and told them, please form a working group. Had a long discussion. So, you know, this is 2022 now. We are after 2020. So as Marcus has pointed out, this is no longer these meetings where all the technical work gets done on a whiteboard for a week. But we still have interesting technical discussions in those meetings. And in particular, the UTC was pointing out that we need to be careful not to hamper usability of those scripts with, by mitigating security issues with too large a hammer. I think we did a satisfactory job of that. Right. So the UTC created a working group. And there were some people listed on that action item. But we also brought in more people through contacts in other companies. I want to point out that this is really a case where the structure of the consortium shines, because we brought in people with expertise from IDE development. I'm thinking of Nathan Lawrence from Apple. We brought in people from Microsoft. Barry Dorrance was on the previous slide. Steve Dower was not on the previous slide, but we found him. And those people had expertise that we did not have in the Unicode regular attendance. And it so happens that the chair and vice chair are employees of Google, but we got really expertise from multiple consortium members. In fact, one of the people in the group, Richard Smith, previously mentioned, also suggested we bring in the chair of ISO AEC JTC1 SC22 WG21 SSG16. That's the folks who deal with applying our standards in the C++ world. And going forward, I'll just call it SG16 because it's a bit of a mouthful. So that's Tom Honorman was brought in there. And so we started working and to bring everybody up to speed on what the problem was, on what we wanted, what we didn't want. We initially were working on that principles document. And quickly we found some roadblocks. Right? It was getting clear that we wanted to do something with those higher level protocols. And then we found some text in the standard that says use of higher level protocols is discouraged. And it in fact says for security reasons. Well, we want to use them for security reasons. So we tweaked that wording a bit. And via our discussions with the SG16 folks, we found out that some of those characters that you might want to insert in there to fix the issues, we recommend their usage, but the SG16 folks thought, this isn't relevant to us. We're not that kind of language. So we tweaked the wording there as well. And we added a lot of examples, right, to actually understand what we're trying to get across here. But this is all still stuck in Unicode Standard NX9 and Unicode Standard NX31, which, as we said, are big and no one's going to look there, and they are getting bigger because we're sticking more stuff into them. But we got that very quickly into the standard, so we proposed that in March. The working group was formed in February. That ended up being published in Unicode version 15, so that's in September of 2022. Okay, but we still need to do something about those standards that no one looks at and that are getting ever bulkier. And we have too many of them. So the solution is we are going to make more of them. But we are going to target that at a specific audience, right? If you are a programming language designer, an IDE developer, some sort of programming language linter developer, compiler, warning writer, something. And there's a lot of overlap, of course, between those audiences, right? Because a language designer is going to often be a compiler writer. Compiler writer also writes the warnings, writes the linter. People who write linters and people who write IDEs are pretty much the same. So that general audience was our target for this new document. And the document makes specific recommendations because a lot of the existing Unicode annexes tend to say, well, you could do that. Could do that other thing. You could also do that. Oh, by the way, hashtags. You could do that for hashtags. And, well, you might eventually find somewhere 6 paragraphs down in the 5th section, something that says, oh, in those circumstances, you probably want this one. By that time, everybody's asleep, of course. So here we are telling you from the start, OK, you are this kind of case-sensitive language, pick this, this, this. You are that kind of case-insensitive language, pick that. And of course, people can be opinionated and do something else, but we let opinionated people be opinionated. But we give people who don't have particular opinions have a clear default. So we presented the plan for essentially that short table of contents to the UTC in July 22. And we said we are going to come with a draft text in November, so 3 months later at UTC 173, to which the UTC said, OK, that's ambitious. And the UTC is an honorable technical committee, but we did it. We ended up presenting some text to UTC 173, which was published as a proposed draft. We kept refining the text after that, but we advanced to the next stage at the next opportunity. And then we waited because this needed to be aligned with Unicode, with the release of Unicode for all the cross-references with all the other Unicode annexes to work, and also because we needed some new properties and property changes. However, this document does not need to be synchronized going forward. It's not like collation where we need to have a new release of it. So hopefully it's a smaller workload going forward. It also means we can quickly fix things. We don't have to wait for Unicode 16 to fix things, which is good because we recently noticed that I made a mistake somewhere. Right. So one novelty in that technical standard is we discussed language evolution. In Unicode Standard NX31, the hypothesis is that you know exactly what the requirements of your programming language are going to be in all eternity. You get it right the first time, you pick that definition, and you stick with it. And that's very optimistic. Another thing also is really we expect you to stick with the thing you picked, but also be ever watchful for updates to the Unicode standard, because we might change our mind on what the recommended default is. And we are careful about compatibility, but if you skipped a few versions of the standard, it might not be completely obvious what was going on. And programming languages tend to evolve on much longer timescales than the Unicode standard. So you end up with a lot of programming languages. So Ada and C# were in that situation where, are still actually in that situation where they are using a definition from Unicode 3 or thereabouts, which was the recommendation at the time. And they never noticed or they never understood the implications of switching to the current recommended definition, even though it's compatible. But we don't spell that out. And then there are multiple identifier definitions. There's the one that's meant to be forward as well as backward compatible. Some programming languages, C++ and Swift in that list, picked the one that guarantees forward compatibility, and then realized that has a lot of nasty interactions with normalization and so on, so they decided we should switch to the other one. Now, the one that guarantees forward compatibility is called immutable identifiers, and the understanding is you're not meant to do that. It's immutable. So, but okay, you have some serious architectural problems there. How can you give you a path to migrating to the right default without breaking users? And that's a problem for language standardizers because they don't want to break programs. That's also a problem from our standpoint. Again, adoption of non-ASCII identifiers is not a done deal. And if you start having, even if the language standardizers are okay with that, if people start breaking programs because you're not using ASCII identifiers, that's not good for that's not a good look for non-ASCII identifiers. And as part of that work with our programming languages, we established a liaison with SC22, the subcommittee for programming language standardization in ISO. So that would cover Ada and C++ in that list. Right. Yeah, I want to talk about timelines. This went fast by standardization standards, which, everything is slow. But I want to compare it to other Unicode technical standards. So we've heard about the emoji, so 51 emoji, 55 this one, source code, 46 IDNA, 36 and 39, that's security. This went quickly, and in particular, most of the work was done in that ad hoc group. So by the time this got to the UTC, that ad hoc group also reported to the properties and algorithms group. So if we did anything fishy from an algorithmic or property standpoint, we would be told off. And so by the point it got to the UTC, the text was in a pretty good shape, and we didn't get we got some feedback, but we didn't get major restructurings out of UTC meetings. And that has not been the case always in the past. You can see that 51 has been in a working draft state. That's, we have documents in the registry, but we're not so confident that we are publishing it as a candidate for a standard. So that stayed in that state for quite a lot longer. 46 took a long time, but that's also liaison relationships with other standards bodies, so that's complicated. 36 and 39, the security stuff, that's interesting. I had to bundle them together because 39 started as appendices to 36, and the Unicode Technical Committee at some point said, take those out of this one standard and make them their own standard. And this is the kind of stuff that would happen in the UTC back when it was on those whiteboards. That's before my time, so it's all hearsay. But you had major structural revisions at the time decided by the UTC on that quarterly cycle, whereas here we were operating on those weekly meetings, and we were able to get the standard in a really good shape, at which point it sailed through the process of actual approval. Right, we have a standard. We're done. Well, it needs to be implemented. So we started. I started implementing some of the algorithms that can be implemented in ICU. There's also implications for programming languages. They need to allow the right things so that then you can insert the right things. That is work that needs to be done with the standardization groups for programming languages. I'm the liaison for that, so homework for me. And then in the broader perspective of things, we've seen from the IDNA presentation that there are a lot of checks that you can have on the structure of text in order to avoid some kinds of confusability altogether. UTS 39 isn't quite there. And so there could be improvements there if we can find people who to put in the time to improve Unicode Technical Standard number 39. I'm staring at the room. Right. Well, that's it. That's the standard. Go read it. Questions?
Great. We have time for a few questions. Someone's got to have some questions. There we go. I'm going to bring you a mic. Can you pass down the mic? Mihai, can you pass down the mic?
So just
make sure it's on.
I'm not hearing myself. Oh, okay.
Wrong. Okay. So I'd like to know how far you had progress with the various IDE and text editor creators
So
in supporting
some
this.
of the IDEs started implementing our recommendations before we had finished drafting them, because we were in contact with those people, right? So we could work those channels to tell them, yeah, you're going in roughly the right direction, and we'll iron out the specifics eventually. So in particular, Visual Studio Code fixed the issue reasonably promptly. I'm not sure what's going on the Apple side. You can ask your colleague, Nathan Lawrence.
But also IntelliJ, for example, is one that's widely used and things like that. Is there like a priority for approaching these people and saying, you really got to adopt this?
I don't think we've been in close contact with people, Mark.
I mean, we had really good contact. We had, of course, very good contacts with people who were directly involved in this, and as Robin said, benefited tremendously by having people from these different disciplines involved in the whole effort. So I think they're probably furthest along. Others, we don't have any sort of outreach program for IntelliJs of the world at this point. But anyone with people with contacts in this group is certainly welcome to help spread the word.
I have a question. So on the slide toward the middle, you had the example of the identifier A1 Hebrew, and you said we fixed it. How did you fix it?
So the Unicode binary algorithm exists, and you can apply it, and it's going to reorder stuff, right? So what you do is you reorder things according to display order. So whatever that thing in memory might be, A-Aleph1 or A1-Aleph, you apply the binary algorithm to it, and you get A1-Aleph. You also need to do some tweaking with respect to mirroring and combining marks, but let's not get bogged down in those details. And then you do the normal confusable thing, because this thing could also be the left to right Aleph symbol, which is a different character and which looks exactly like an Aleph, right? So you have the normal confusability on top of the reordering. So you need to do both, but that's basically the fix. Bring in the bidirectional algorithm and take the display ordered skeleton, as we call it.
Yeah, just to add a little more to that, what you typically do for confusability is you will take a string and you map it to what's called a skeleton, which represents something that will be a sort of semi-normalized form and allows you to very quickly look up and see if there's something that also has that same normalized form. So it takes the problem of having end-to-end mappings and makes it very simple.
Yeah.
And so by applying the BIDA algorithm on top of the other normalization forms that you would use, that kind of comes in for free. So it turns out to be a fairly straightforward extension of what we had already done.
So to elaborate on that, for ordinary homoglyph confusability, you might have a mapping of 1 and L to the same thing, and I forget if it's 1 or L. And here you're mapping the string to the reordered string and then doing the normal confusability mapping. So you might turn this 1 into an L here.
But Robin and Mark, even if we understand this, we can figure out that there are many co-point sequences that lead to a display like this, similar or exactly like this. The question, I think, or maybe was, so if you know that there are many different things that can look the same, what are you going to do then? Yeah.
Well, Marcus has.
So the goal is not to basically forbid an identifier or one of the possibilities. The goal is to prevent confusion. So if you have two variables or two functions in your program that are spelled differently but look the same, that's what this is trying to prevent. It's not trying to forbid you from using one or the other spelling, but it's trying to prevent you from using both of them and be confused which one is which.
So what are you doing if you have these identifiers in different files and you have a programming language that doesn't necessarily, like C, for example, include all the stuff and compile it in one go?
That's a higher level protocol. But
So
the standard does, I will say, like, this was a big topic of discussion at the beginning of this, and the standard does like try to talk about different programming languages in a generic way, because not every programming language even has a concept of warnings, or like, some programming languages only have errors, like errors, warnings, parse errors. All of these are different categories. You can go very deep down this rabbit hole. You're trying to give high level recommendations that then the programming language can apply to themselves how they need.
Yeah, I mean, one of the things that that the people involved in the working group did is looked at how their environments dealt with variables in scope. And so they did some analysis of it to make sure that it was feasible to apply these sorts of issues to identifiers and handle the scoping issue efficiently within modern programming environments. And that's one of the reasons why we ended up with the solution we did.
We have time. We have about 2 more minutes left in this session. Does anyone else have any more questions? Otherwise, we can spend the last 2 minutes in the weeds on this question. Okay, Martin, go ahead.
Okay, so, but then if you have the scoping right, you can actually have one confusable version in one scope and another confusable version in another scope.
Yeah. And as long as
okay.
they are not in the same scope, the warning won't trigger. Again, like whether you're warning or whatever is a high level concern, but as long as they're not in the same scope, that's fine.
So Martin, we foresee multiple options here.
Okay.
Right, and
what are you going to do? Multiple options.
Well, there are multiple options because not all programming languages are C, and depending also on how heavy the hammer is that you're applying. If it's some kind of lint warning, and in stupid cases you can ignore it, then you may be okay with false positives. Maybe in some other cases this is unacceptable. So yes, there is some complexity here. We foresee a number of possibilities here. You might be able, depending on who is implementing it, what you are doing is going to be natural, right? If you are in the guts of the compiler, it's fairly easy to take all the names that are in scope and map them through to their skeleton and see, even do the name resolution on the skeleton and say, okay, if everything were its skeleton, I would have this ambiguity. Something's fishy here.
Thank you, Ramon, for your presentation. Let's give Ramon one big round of applause.